don't know, there may be a few things you wanna jot down on this as we go through these review notes. Oh, I grabbed myself a copy of the review notes. Right, hold on. 7.1, when we did section 7.1, we just basically talked about the HO and the HA and setting up stuff. We did the p-value stuff there at the beginning, but we didn't use it the whole rest of the chapter, so I'd sort of, I mean, you can do it that way. Lily wants to be a knucklehead and make Ebersole actually think on the test and go think really hard and have to figure out how to do the p-value and everything.
What did I do?
We didn't really use it, so the type 1 and type 2 error, we didn't do a whole lot with that. I don't think there was anything on the review packet about it, so there probably won't be anything on the test about it. Some of the charts, remember that this chart is in your charts here somewhere. Make sure you can find it. Decide how to reject and fail to reject the HO.
And which one always has like the less than and greater than?
It's, yeah, so and that's probably something we ought to write up here. So the HO's always got, it's either less than or equal to, greater than or equal to, or equal to, and then the HA is always less than, greater than, or not equal to. And remember, wherever I've messed up and put it in here, look at this one to figure out, you know, whether you're right-tailed, left-tailed, or two-tailed. Remember that if it's this, it's left-tailed. If it's this one, it's right-tailed. This works for the whole chapter. If it's this one, it's two-tailed. That first section, we really didn't do a whole lot with it. The second section, we actually started doing all the stuff. The one I've listed on these other pages, and it's sort of hard to read because I probably should have printed it up a little better and put them together, but smaller or something. So 7.2, we actually started doing the testing. State your HO and HA first. And a lot of these were basically the same things over and over again. This is your Z chart. That's the very front page here. And remember that I think on the Z chart, everything that I probably put on the test just uses this little chart right here. And remember on that little chart, L stands for left-tailed, R stands for right-tailed, and then 2, of course, stands for two-tailed. Let's go back a second. Here also, this is where you're going to draw your picture. So draw your little normal curve and do all that stuff. And I'm only going to do all this for the first one. They're all basically the same thing. Number 6 here. I'm going to rewrite this formula. It's X bar, remember that's your sample mean, minus mu, which is your your claim, whatever they're claiming, what mean they're claiming in your HO or your HA.
So which one goes first?
X bar. What do you mean?
So like the same thing we use.
Yeah, when you're doing the formula. And then sigma over the square root of n. Probably won't know sigma, so you'll probably put s in its place. You find that, once you find that, then you look at your little chart, whatever tail you were, you see where your z is, and you see where your z falls on that chart, and that tells you whether to reject or fail to reject the null. Once you reject or fail to reject the null, then you interpret it. Number 8 here, remember the interpretation. Has 3 parts. First part, you say is where your alpha is. You say with a 5% level of significance or whatever. Your second part is the part that comes from the chart. That comes from this chart. Right, my arm's in the way. And then the third part connects it to the problem. So again, it's going to say something like, and I'll just pick one of these at random here, it doesn't matter which one. If our alpha was 10%, it'll say with a 10%, and you're writing the same things over and over again, except it changes a little bit as far as the percent goes, and it changes as far as which one of these you're using, and it changes according to the problem. So it might say something like, with a 10% level of significance, there is not enough evidence to reject the claim that the mean test score in the prob stats test for the chapter 7 test is higher than 82%. And those, everything else for the rest of the chapter, this is section 2. Section 3, Section 4, Section 5, basically the same thing, just changed a little bit here and there, but basically the same steps over and over and over again. We just talked about that and interpret the decision. You know, if your claim, oh, that's probably something I should have put back at the very beginning too, back at number 1, make sure that you label on the number 1 of your steps, make sure you label which is the claim. So whether the HO or HA is the claim, make sure each time you label it. Most of the time I put like HO, HA, and wrote out whichever one it was, you know, wrote out whatever they said. And then you decided, okay, this one here is the claim, so you just wrote claim right there. Make sure you label that each time. The second one was for small samples. So 7.2 was samples larger than 30. This is for n less than 30. For small samples, doing the same thing, you're stating your HO and HA. Again, tell them which one is the claim. Identify your alpha, your level of significance, they'll tell you that. This time you gotta find the DF. Remember, DF is just n minus 1 degrees of freedom. And then you're using the table. This time, instead of using the Z chart, Instead of using that little chart on the front, instead of using this chart, now we're using the T chart. I think I grabbed the wrong packet. Your guys' packet's different than this one. Can you guys find your T chart? I think your T chart's like the third thing or something.
For us, it's table 5.
Yeah, it's table 5, but isn't it like the third page or something? Or is it way back in there?
It's kind of in the back.
Oh, okay.
It's about halfway through.
And I think on the table, did we fix this?
I have it fixed.
So we fixed that,
Yeah.
instead of looking at the HO, make sure you look at the HA. Get rid of that I had printed up there.
Question.
Yep.
Alright, so like the T, what does that stand for? It's just like, just nothing?
It's just, yeah, it's just a T distribution. Yeah, it's just like C is just a, I don't know, maybe the guy who figured it all out, his name was Thomas, and he wanted to use his initial there or something.
Hidden Z is exact.
Right, right. So determine any critical values, you're gonna draw your little thing, draw your little, bell curve again, figure out if you're one-tailed, two-tailed, whatever. Figure out these critical values here from the table. With the table, remember we use degrees of freedom. You gotta know if you're one-tailed or two-tailed first before you start doing this. And you go over, and if you're just one-tailed, you use your degrees of freedom and you go over to your level of significance. And if you're two-tailed, then you use the other one, the one below it. And I'm sure that's on this same slide. Determining rejection regions, number 5. Somebody help me out real quick, make sure I don't mess this up. When we determine the rejection regions on this, did we have to, if we were two-tailed, did we have to do something special?
I just looked at the first negative and
It was just a negative and a positive?
I think so.
Is that what it was? I'll have to look at that. I think there is something special that we have to do here, so you might put a little star beside that. I'll look at it. The formula for number 6, figure out your test statistic. Again, I'm just gonna rewrite this. X bar minus mu over S divided by the square root of n, same as the other formula. Number 7, decide whether you're rejecting or fail to reject. And number 8, interpret again. And I'm not gonna write all that out again, it's the same thing. Doing the interpretation the same way, 3 parts. Somebody look on your chart for me. Use a DF of 19 and a alpha of 10, or 10%, 0.10.
And what is it, 1 or 2?
Two-tailed,
You say DF and what?
19.
1.328. No, you said 2.
1.729, so it is just the positive and the negative, all right. So we're okay there. Same as the other. I thought there was a little difference on that one. Next one, 7.4, z-test for a proportion. Remember, this is like your, I hate to put that up there, but it's like your percentages The first thing you're supposed to do every time, which we didn't do most of the times because I always forget, is make sure that n times p is greater than or equal to 5 and n times q is greater than or equal to 5. Just, again, to check this, you really only have to check one of these. Just find the smaller of the two. And you might want to write down with this, remember that, how do you find q? What's q?
Yeah. All one minus.
1 minus p, and if it's q hat, p hat, same thing, right? So it's 1 minus p, and you also might want to write down too that p hat is x divided by n. X is the number of positive or yeses or whatever in your sample, and n is the total number in your sample. Some problems you may have to find p hat, you may have to find the percentage or the proportions before you can go on with the problem. But then, for it to fit all this stuff that we're doing, n times p has to be greater than or equal to 5, n times q has to be greater than or equal to 5. How many problems do you think I put on the test that they're not greater than or equal to 5?
0.
Probably none, because then you wouldn't have any work to do. You'd just say, hey, this won't work.
Come on, man. Thought you liked this.
So number one again, HO and HA. Specify the level of significance is number 2. Find your alpha. Number 3, sketch the draw. One-tailed, two-tailed, all that stuff. Why this is all different colors and crazy stuff, I don't know this time. Determining critical values. Look up your alpha on the chart. If left-tailed, look up 1 minus. If it's right-tailed, look up 2 minus. Remember on this, all this here, and we really don't have to do that. Just use that little chart. I've done all that for you on this, using this little chart. I've separated it all off for you. So this part here, you really don't have to, that's the way you'd have to do it if you had to use the big chart here. Use the little chart just like we did on section 7.2. Determine a rejection region, so draw it on your little graph. Find the standardized test statistic. Again, I'm going to rewrite this. It's p hat minus p over the square root of p times q divided by n. This one's not I don't want to say it's tougher, a little different. Please make sure, and I know we did this as we were going throughout the chapter, make sure that you do it in a way that you know you're getting the correct answer. So don't try to plug it all into your calculator unless you know for sure that's giving you the correct answer. I always like to do all of this first, then I take the square root, I write that answer down, and then I figure out what p hat minus p is. That's usually not too hard to do. You can usually do that in your head. And you just take that answer, whatever you get on top, divided by whatever answer you got on bottom. That way I'm sure I got the right answer. Then you check it, so you're looking at your drawing, whatever your little drawing is, you look at it, and if it's right-tailed this time, and you check to see where that falls at. If it falls in the white area, the unshaded area, then you fail to reject. If it falls in the shaded part, then you reject the null. And then number 8 again, you interpret. Afraid you get tired of hearing the same thing over and over and over again. think that was section, what was that? 7.4? That was 7.4.
Yeah.
Then the last section, 7.5, dealing with variance. This one's a little different because you're doing the chi-squared stuff. So it's dealing with variance and standard deviation. Still, state your HO and your HA. Number 2, figure out what your level of significance, your alpha is. Number 3, find your DF, your degrees of freedom, n-1. Number 4, this time we use a different table. This time we use the chi-square table. Make sure you can find it in your packet there, because I think one of the packets that you had, so make sure you got all these tables in there, because one of the packets doesn't have the chi-square in it, I don't think. And again, on the chi-square, on mine, it's got those, my screw up top here. Did we change that?
Yeah,
On yours?
We do.
Alright, so make sure that that's changed. Remember, when you're drawing your chi-square this time, it's not the same. Chi-square graph looks like this. It's all positive. It's got like the hump, and then just the one tail off to the right. Then you're going to decide whether you're left-tailed, which would be over here somewhere, or if you're right-tailed, which would be over here if you're two-tailed. And that is a little more difficult. We'll talk about that here in a second. You got to do actually a little more work because you can't just have the positive and the negative. Determine the rejection regions. Yeah, maybe I won't talk about it. Number 5 here, when you're determining the rejection regions, if you're left-tailed, then the chart just tells you. If you're right-tailed, how would we do it if we were right-tailed? I gotta remember now. I have their notes there close. This wasn't that long ago. Let's see, right-tailed. Somebody look this up on the chi-square chart for me. So our DF is 13, and our alpha is 0.01. DF is 13 and alpha is 0.01.
27.618.
Oh, I said it wrong. That's why I forgot this chart's backwards. Could have helped me out and told me that. If it's right-tailed, you just use the chart. Alright? If it's right-tailed, you just use the chart. Find a place to write this. So right-tailed, remember the chart's backwards on these, that's what I forgot. Just lay like this. If it's right-tailed, you just use the chart. If it's left-tailed, then we got to do 1 minus the alpha. And we use that number with our DF on the chart. Trinity, did I screw it up and now you're going to just be completely and totally lost? If you're two-tailed, alright, two-tail up here, and then it's out of order. If you're two-tailed, you have to do alpha divided by 2 get that number and your DF, look it up on the chart, and 1 minus alpha divided by 2. That's horrible. So right tail, chart and DF, left tail, use, you gotta do 1 minus alpha, then use the chart and the DF. And if you're two-tailed, you gotta do alpha divided by 2 and 1 minus alpha divided by 2, and then take both those numbers and your DF and use the chart. I think there's one on the review packet there, we'll do it here in a second. Number 7, make a decision whether to reject or fail to reject, and then number 8, of course, is interpret the decision. So that's probably the hardest one, but it's not really hard, especially it wouldn't be hard if I could remember how to do it and didn't confuse everything so bad. On the review packet, we'll go through as much of this review packet as we can real quick. I'm going to skip to look at problems 14, 15, and 16. I'm going to skip to those just because that's the ones I just messed up, and I want to make sure that you understand those since I screwed it all up. So 14 says your right tail. First thing I messed up was forgetting that chi-square chart. On your z-chart, the z-chart always tells you the area from a spot to the left. The chi-square chart tells you the area from a spot to the right. It's backwards. That's the first thing I messed up. So if you're right-tailed, all you're going to do on this, you find your DF. What's our DF if our N is 14? 13. So you find DF is 13, our alpha is 0.01. We're right-tailed, so that means we're going to be here somewhere. Look up on the chart, 13 and 0.01, and what's it tell you that your critical value is?
27.688.
So that's if you're right-tailed. If you're left-tailed, so now we're over here somewhere. You find your DF, what's our DF?
6.
And then what we have to do with this is we subtract it from 1. So we do 1 minus 0.05. What's 1 minus 0.05? 1 minus 0.05, what'd you say?
0.95.
Oh. Sorry.
You don't work with money, do you?
No. Well, I do sometimes, not all the time.
Because if I came in and gave you $1 and you were supposed to take a nickel out of it and you gave me back another nickel, I would be pretty upset. So now what we do, so now what we do is look up 0.95 and 6 on the chart, and what's that tell us? And it should be a smaller number because we're on the left table.
1.635.
Is it negative?
No, there is no negatives on the chi-squared, everything's positive.
Just
Our two-tailed, So we're gonna have a tail over here and this part. So we got two critical values this time. Our DF, what's our DF this time?
80.
And what we have to do on this one, we're gonna use the 80, but then we have to have two numbers to use. We don't just use alpha, we take alpha, which is 0.10, divided by 2, that's the first thing we use. What's 0.10 divided by 2?
0.05.
So we use that, somebody do that, 0.05 and 80, what's that give us off the chart? Where do you think that's gonna go?
The right side.
101.879. And then for the other one, we just take that number that we just got, and hopefully Lily does better this time, and we just do it like we did up here.
0.95.
Just 1 minus that, and 0.95. And we look up that number in 80, what's that give us? And it should be a lot smaller than this 101.
60.391.
So those are our two critical values, and these are our rejection regions. I make it all better, Trinity. You can understand that now. All right, now we'll go back to the beginning, unless you guys want to start somewhere else.
We do like 13.
Yeah, 13.
We'll go backwards. Wrong direction. A polling agency, I'm gonna read it off here so I don't have to move that. A polling agency reports that 20% of US adults are without health care coverage. In a random survey of 1,420 US adults, 256 said they did not have health care coverage. At a 2% level significance, is there enough evidence to support the agency's claim? So first thing with this one, the first thing we gotta do is we have to find P hat. And to find P hat, we take how many said yes out of the total of our sample. How many said yes, or how many said that they don't have health care?
256
Out of a total of how many did they have?
1420.
What is it?
1,420.
1420. Somebody divide that for us, tell us the decimal. You go out 2 decimal places.
0.18.
So 0.18. Now, I broke this up into all the steps. I don't know if I don't think it's this way on the test, but, so first thing we do, we state our null and our alternative hypothesis. Remember, that comes from the original claim. The polling agency reports that over 20%. So, first thing, it's gonna be a P, but it says over 20%. What's that mean?
Greater than.
Greater than 20%.
So it's an HA.
So that's the HA. So put that down here, and instead of 20%, I'm gonna put in 0.20. That's our claim. Make sure we label it.
Then less than or greater than.
Less than or what?
Greater than.
Less than or equal.
Equal to.
So that's our HO and our HA. Next, we're gonna draw our little graph. We're gonna find our critical values. Looking here at our HA, are we left-tailed, right-tailed, or two-tailed?
Right.
Right there.
Our graph looks something like this. You get a point if you just draw the graph with the right tail on it. We go to our charts. We're using the Z chart this time. That means we're gonna just use this little chart right here. What was our level of significance?
0.02.
Ah, so maybe we can't use that chart because it's not on there, is it? So 0.02. And we're right-tailed. What you're gonna have to do this one, maybe I changed this on the test so that you could use that little chart. You gotta look up, turn to the back of the first page. You gotta look up. The area. Now, since we're right-tailed, remember the Z chart shows the area, and this is a whole lot more difficult than I think I put anything on the test, and if not, I'll make sure and I'll change it before Friday. But if this part's 2%, what's this part over here?
Would it be like
0.98.
Oh,
So we're gonna look up whatever's closest to 0.98 on here. So we're using the chart backwards. Try to figure out what's closest to 0.9800.
1.2.
It's like right in the top left corner.
Which chart are you looking at?
You said which one? You said the back of the first page?
Back to the first page, yeah.
Uh,
So we're trying to find this. We gotta use the chart backwards. I know we did this like at the very start of the chapter once, and then we didn't do it anymore. So you're looking in here to find the number that's closest to that, then we're gonna have to,
0.9803.
0.9803, is
Yeah.
that the closest one?
I think so.
Would 0.9798 be closer?
0.9798, which one's closer?
Which one do you
Right.
want?
I want the one that's closest. So 0.9803 is like 3 spaces away, right?
Yeah.
0.9798 is how many? 2. So which one's closer?
9798.
So 9798, that's the one we want. Now you look over here, and you look up here, and what's your number? 2.05. That's our number right here, 2.05.
So you're not doing this in the test?
I hope not. But if I do, you know how to do it now, so.
Maybe. I don't know.
So that's our rejection region, that's drawing our little graph there. Part C, find the standardized test statistic for this. The formula is p hat minus p over the square root of p times q divided by n. What was p hat?
0.18.
0.18.
P was 0.20, is that right?
Yeah.
That comes from the claim. What's P? 0.20 again. What's Q then if P is 0.20?
0.80.
0.80. And N?
Is 1420.
1420, is that right? Now again, you might want to make sure you're punching this into your calculator so you can see if you're getting the same answer as everybody else, because it seems I remember when we did these, we got about 12 different answers and there's only like 10 of you in the classroom. I'm gonna correct this one, so I don't need one. First I know it's gonna be negative. If I get something sort of close to this.
Slightly different.
On my paper, I actually got this, because I must have rounded off a little more when I did it.
Ooh.
Is that what anybody else got?
Mine was close.
What is it?
1.87.
About like 1.87, but I rounded it up. It was like 1.8 or 1.8.
1.88. That's pretty close. As long as you got the negative, the thing that matters here, when this comes out to be negative, and we could, this number really doesn't make a whole lot of difference because our graph looks like this. This number was what, 2.05 or something like that? Is that what it was? As long as it's negative, where's that gonna fall at?
Right there.
It's gonna fall over there somewhere. It's not even gonna be anywhere close to our rejection region. If it's negative, if it was positive, then it'd be close, but if it's negative, it's not gonna really matter. So we know it falls in this, and what's that tell us? It falls in the other. Fail to reject the null. Then to interpret our results, I probably don't have the space down here, so it's all right if I write it up in this area. With, somebody help me out, what was our alpha this time?
0.02.
So with a 2% level of significance, I know the first word is always there for the second part. We grab our chart. Let you guys tell me this time which one we're using. We're looking at this chart. How do we decide which one to use on this chart?
If we rejected it, then whichever one the claim is.
So which one was the claim?
HA.
HA was the claim, so which column did we look at?
It's the top right one is the one we want.
This one here?
Yeah. Because you rejected. No, you failed to reject, sorry. It's the bottom right.
So this one down here?
Yeah.
Does everybody agree with that?
Yes.
And what's it say?
There's not enough evidence to support the claim.
What was the claim?
That over 20% of U.S. adults are without health care coverage.
We're just gonna keep going backwards, or what are we doing?
Yeah, community number 12.
Number 12 says, Fitness magazine advertises that the mean monthly cost of joining a healthcare club is $25. You work for a consumer advocacy group and are asked to test this claim. Does anybody know what a consumer advocacy group is?
And test food.
Maybe. It's one of these groups that goes around and tries to prove that, hey, you're lying to everybody. They try to prove that something's not right so that they can catch a business in a lie or something. So that's, it's somebody who's supposed to be helping the consumers out. And that's right. You find that a random sample of 20 clubs has a mean monthly cost of $26.25 and a standard deviation of $3.23. At a 10% level of significance, do you have enough evidence to reject the advertiser's claim? First of all, if this is got, if our sample has 20, can we use the Z stuff? To use Z, it's got to be more than what?
30, so you can't use.
So we have to use
T.
the T stuff. First, we want to state the null and alternative hypothesis. What was their claim this time? Cost to join a health club is $25. So what is that? Is that the HA or HO?
Good job.
Yeah, it's an HO.
So the mean cost, so it's just gonna be mu equals 25, that's the claim. What's our HA gonna be then?
Not easy.
That tells us that we're what? That we're two-tailed. Find the critical values on the table and draw the graph. I didn't leave myself any space down here, so I'm gonna draw it up here. So we're gonna do this. We're two-tailed. We can't use the little chart this time because we're on the T chart. So we've gotta find the T chart on here, which is, you guys tell me it was back several pages. It's chi-squared. There it is. Right back there with the chi-squared chart. So T chart, first thing we got to find before we can find our critical values is what?
Your degree of freedom.
Degrees of freedom. If we're 20,
So it's 19.
so 19. So we're using 19 and the level significance of 0.10, and this one's just gonna be a positive and a negative of our answer. Remember, we're two-tailed, so make sure you look at the correct line. What's that tell us? 19 and 0.10 for two-tailed.
1.729.
So negative 1.729 there, and a positive 1.729 there. So that's the second part here, that's our rejection regions in our graph. Find the standard test statistic. Formula this time is x bar minus mu over, it's the same as the other one, s divided by the square root of n. What was the x bar? So I don't have to keep trying to look back. Wasn't it like $26.25 or something?
Yep.
26.25 minus mu was 25. S standard deviation $3 and something. I don't remember what it was.
23 cents.
$3.23, and then N was 20, right?
Yep.
Again, some of these, like this one, I can do that top in my head. That's 1.25, right? I would do this separate, then go back and do that. So in my calculator, I would type in 3.23 divided by second square root of 20, it equals, and I got that number right there on my calculator. Then I would type in 1.25 divided by, and I still got that number right there. And you guys can probably do it easier than I can. There's probably other ways to do it, but I just type it in again. 0.722249956 and you probably really don't have to go out that far, but
1.73,
1.73 we'll say. Now back, our graph is, my graph's on the other thing, so I don't have it here. What was our critical values here? What were they again?
1.729, so it falls in the shade area.
So 1.73, this one's really, really close, isn't it?
Yeah, it's literally right on the line.
It's like, right there, so, or no, I'm sorry, right, I went to the wrong side, that's a negative. It's right there, just really, really close, so this is one you might wanna, you know, if you were doing this survey, you might wanna be careful calling them liars, because you made a little math mistake somewhere, and it comes out that it actually fell, you know, right next to it on the other side. So this one will say, since it fell in there, that means we're going to reject the null. Again, I don't think I put anything on the test that is gonna fall quite that close. Instead of me writing this out, can I just say the interpretation? You guys let me know when you're ready.
Ready.
With a, what was the alpha?
0.1.
So with a 10% level of significance, there is, and then we gotta look it up on the chart. Which one was our claim? HO or HA?
HO.
So, and we rejected the null, so
There is enough.
there is enough evidence to reject the claim. There is enough evidence to reject the claim that the mean cost to join a health club the mean monthly cost, just to make Lily happy, the mean monthly cost to join a health club is $25. So with a 10% level of significance, there is enough evidence to reject the claim that the mean monthly cost to join a health club is $25.
Reservation.
Other questions? Couple minutes.
You said what?
We do the front page 5, 6, and 7.
Use the given information Z table to find the Z value. This, these two,
This one we have to,
these two are gonna be easy. This one here is like the other one that we just did with the 2% a couple minutes ago. So on this one, if we're right-tailed, and we want to find the critical value, so we're figuring out this value right here. You can just look at the small chart, and we're right-tailed in 0.01, and what's it tell you?
2.33.
That's your answer? Let's skip number 6, and we'll do it here in a second. For two-tailed, if it's 1%, 5%, or 10%, then we can just use this little chart here that I made out for you. So for two-tailed at 0.05, what's our two numbers? What's on the left side? So we're looking 0.05.
Negative 1.645. No, I did it. Yeah.
Look again.
1.96.
All the two
For
days,
two-tailed.
right?
So negative 1.96
That's positive 1.96.
and a positive 1.96. On this one, we're left-tailed, that's over here. This makes it a little easier than the other one that we did. Because if we're left-tailed, now all we're doing to find this number is we're looking up, we're saying that the area here is 0.08. So we're trying to find on our chart, in these numbers,
I thought we tried to find the rest.
we did if we were right-tailed. Because then that would be the area over here. Remember, the Z chart tells the area from there to the left.
We have 0.0808 and 0.0793.
So which one's closer, Ken?
Maybe, 0.0793.
So now, find that on your chart, 0.0793.
Negative 1.4 and what's
So negative 1.4, and then the other number just tells us which number to add on to the end, which is 1. So our critical value there is negative 1.41. Maybe I'll be nice and I'll take that off, or maybe I won't, I don't know.
It just gets confusing, like, if you have to subtract, like.
Right, you just have to remember if you're, we did this way back at the start of the year, or towards the start of the year. If we're here, the chart tells the area from this way over, so we're just looking for that area this time. If we're doing a right-tailed, the chart still tells this area, so we want to, if it was this one, we would want to look up the area 0.9200, so that that 0.08 would be the area going off to the right. Other questions? We'll be ready on Friday?
Yes, sir. Yes, sir.